Okay students, now I am going to explain you the problem number 2.3.8 of drawing number 8. This problem is on a mirror which is of a rectangular shape. Normally when we say mirror, how is it hanged to the wall? This is how you will have the mirror at home, so that you can view your image. Now the mirror has a dimension of 20 by 30. The longer side is 30, the shorter side is 20. So the position what I have shown you now is going to be your third step, the last step. Now how are you going to start with? It's actually a rectangle of 20 by 30, but it should appear like a square of 20 by 20 in the front view. That is what is asked. So 20 mm edge is common between the rectangle and the square. So whatever is common, as per the note what I have already told you, you must start by drawing that perpendicular to XY line. So in this case, because we are in simple position 3, we are going to start with the front view by taking the 20 mm edge perpendicular to XY line. So I am going to place my mirror like this initially. So the 20 mm edge is taken perpendicular to XY line, and this is 30 mm edge. So you will have a rectangle in the front view like this. The top view appears to be a line and the line appears to be on XY line. Now I am going to make it inclined to the wall like this, so that the front view becomes a square. This inclination is so adjusted that when it is projected on the wall, it should appear like a square to you, 20 by 20 square. That is second step. Once that step is done, whatever square you have, okay, that will be rotated by 90 degrees in the front view. So what you are going to do, you are making the same inclination with VP, but you are making the position like this. So that what is asked in the third condition, the longer edges of the rectangle should appear perpendicular to both HP and VP. In this position, if you draw the top view, in that top view you will get both the longer edges perpendicular to XY line. Even in the front view, both the longer edges will appear perpendicular to XY line. They are not in fact perpendicular to VP or perpendicular to HP, they appear perpendicular to in both the views they appear perpendicular to XY line. This is what you should understand. So once again I will repeat all the three steps. This is going to be my first step. So rectangle, this is 30 and this is 20. Now I will rotate the lamina about 20 mm edge like this, so that the front view becomes a square, and then I rotate the entire lamina by 90 degrees. So like this. This is your last step, third step. So this is the 3D scenario, which I will explain in a 2D scenario by drawing it on a drawing sheet. Okay, so the lamina is basically a rectangle. I am going to start with a rectangle in the front view. This is your XY line. As I have already shown you, it's a 30 by 40 rectangle. It's a 30 by 40 rectangle. So 30 mm edge I am going to take perpendicular to XY. So this is your 30 mm edge, which I have taken perpendicular to XY in the front view. This is 40 mm edge. Now I am going to name the corners A dash, B dash, C dash, D dash. Now I draw the top view, which appears to be a line. This is your top view. This is the position of the observer. C is visible, D invisible, A is visible, B invisible. Now this is what is SP3. In the second step, we should convert this into a square. The front view appears to be a square of 30 mm sides. So I'll make this a square in the front view, 30 by 30 square. So I have named the corners C dash D dash. So this edge from 40 it is reduced to 30 now. So what should be the inclination of the surface with VP is what we have to find now. We are going to keep this edge AB on VP. So I write AB here. The point C and D I will project down. Then what has to be done? Take AB as center, this length as radius, which is equal to 40 mm. AB as center and 40 mm radius, you are going to cut this projector, so that you are going to get the inclination of the surface with VP. This is phi. These two lengths are equal. This length is equal to this. So this phi, when you measure, it should come to 41 degrees. This is what you are required to get. So you have satisfied the VP condition here. What is the VP condition? The lamina should appear like a square in the front view. That's the VP condition. Indirectly it is given. Directly, had it been given, it should have been given like this. The surface is inclined to VP at phi, so that the front view is a square. That is direct way of giving. But it is given indirectly, saying that the front view should appear like a square. So you have satisfied the VP condition now. Now let us move to the HP condition in the third step. The HP condition says both the longer edges should appear perpendicular to HP and VP. Where are the longer edges now? AD and BC. These two are the longer edges. They are here in this view, AD and BC. Right now they are parallel to XY. You should make them perpendicular to XY. So you should rotate like this by 90 degrees. So that AD and BC are made perpendicular to XY. So I am going to draw the same square once again here, but the naming will be changed. I have drawn the same square once again here. So A dash, I am going to mark it down here because you have rotated it by 90 degrees. This will be B dash, this is C dash, D dash. Now you can see the longer edges AD and BC, they are made perpendicular to XY. In other words, they appear perpendicular to HP. Now I am going to project this and get the final top view. This is CD. This is the locus for AB, so I can mark A here, B here, and CD, I draw its locus. Project the points down. You are going to get C here and D here. So just connect the points. You are going to get the final top view. This is how the top view appears. Now one important observation here, as you have moved from second step to third step, you have rotated the lamina by 90 degrees. So I have given you a note in the previous class when I have dealt with SP1 or SP2. Whenever a view is rotated by 90 degrees, when you move from second step to third step, if phi is the inclination of the surface with VP, then theta will be 90 minus phi. In other words, theta is 90 minus 41 degrees, that is 48 degrees. This is an observation which you should make. Okay. Though you are asked what is the inclination of the mirror with the wall, which you have already got, this is also there. Inclination of the surface with HP will be 48 degrees. Just now I have shown the final position. I will once again show it. It's like this. The final view is like this. So you got the inclination of the surface with VP now. The inclination with HP will be 90 minus phi. That's what you should know. Let us say this is your HP and this is your VP. The inclination with VP is phi and inclination with HP will be 90 minus phi. This is what you should understand. Okay. So that's it. Problem number 2.3.8. I'll come back to you with 2.3.9 now.